Okay, a very good afternoon. So, in our previous class, we discussed about fixed uh, hydrodynamic bearing, uh, and also we discussed about what is meant by pivoted pad bearing or pivoted slider bearing. A natural development of this pressure, okay, in the pivoted bearing. It is because with respect to the load, okay, when the load changes, the pressure or that is what the inclination, this alpha is also changes. Uh, the pivoted journal bearing uh, is consider its application to the journal by wrapping a number of both such pads around the circumference of the journal. And it is shoes are properly pivoted, they will be free to, means the tip is free to tip in the both circumferential and in axial direction. This freedom of adjustment is one of the great asset, means one of the advantage of the pivoted pad bearing, and for this reason they are frequently used on the properly shafts on ships. Okay, in rough, the water marine, it's also used in the water marines. So these are some examples where we are using. Okay, when compared to the fixed bearing, this pivoted bearing has an advantage, and that's why it is more commonly used. And directly come to the derivations of this pivoted pad bearing, which is more similar to the previous one, fixed bearing. We already have the equations equations of fixed shoes bearing. We have to use same equations. Okay, and only thing is we have to change some of the variables, like we have to introduce one term called m. Okay, it's a most important parameter in pivoted pad bearing. So this is a figure. Okay, a plate, a same plate which was used in the fixed shoes, the same uh, moving plate with a velocity of u. So this is a velocity u which is moving. L is the width of this plate. Okay, w is the load which is acting, and A is at a distance of this load is acting, and H1 is a thickness at entry, and it is a thickness at exit. Okay, and here B is the length, and alpha is the inclination of this pivoted shoes or pad. Okay, in the previous we are used a taper shoes, it is having an alpha inclination, but here this is a alpha which can vary from 0 to maximum. Okay, and here D and E, which are the distances from the left and right side. Okay, and these values, by using these values we are going to derive, but here we are not exactly going to derive, we just change the parameters for the analysis of this slider bearing with the fixed shoes. It is convenient to change the form. We just going to change the form of expression for the load carrying capacity, uh, as well as already a pressure distribution is there, by introducing the dimensionless variable called m. It is called m. We are going to introduce this variable. It's a dimensionless variable. We are going to introduce this value in a fixed shoes equation. Fixed shoes equation. So this term m, okay, you can get these equations in your data and book. Just I will show you. This is a data and book. Okay, here it's a fixed. Previous one is fixed shoes. Now it is a pivoted shoes. Here a alpha is equal to minus m a. Okay, and here this is a load carrying capacity. If you want m equation, see for pivoted shoes, so this is the equation we are using. Okay, so where m is equal to, so m is equal to, which is an h1 by h2 minus 1. Okay, I want m distance means it is h1 minus h1 by h2 minus 1. So we can simplify this m is equal to h1 minus h2 by h2. We can call it as, okay, and we already have the term alpha by a, which is alpha by a term. Okay, we know that alpha from the data and book. Okay, so these we can brought it from data and book. Okay, so alpha which is equal to h2 minus h1 by b, so a is equal to h2 by b. So alpha by a is equal to, I just substitute this value here and this value here, and b get cancelled. Finally alpha by a, it gives h2 minus h1 by h2. Okay, if we take minus common outside, it is become h1 minus h2 by h2. Okay, so which is similar like m. So here minus alpha by a, which is equal to m, means I substitute this value m. Okay, m is equal to h1 minus h2 by h2. I substitute in the place of h1 minus h2 by h2 is equal to m, and here I send minus this side, so that alpha by a is equal to m, and finally alpha I want, so alpha is equal to minus m by a. So alpha means it is an taper inclination angle which is depends on dimensionless quantity m and a. Here, so alpha is equal to minus m by a. See in the data handbook. So it's a pivoted shoes. So here alpha is equal to, so m value they given, m is equal to h1 by h2 minus 1. That is what I taken here. See here, it is also there in the data handbook. Okay, so alpha, these values are also in the data handbook. So I simplified. So alpha is equal to minus m by a, which is in the data handbook. See here, alpha is equal to minus m by a. That is what I derived. Okay. Next, I introduce the term alpha. Wherever the alpha is there, I just replace that alpha by minus m by a in a load carrying capacity. And if you simplify, it gives the load carrying capacity for pivoted shoes. If it is in terms of alpha, then it is a fixed shoes, because that alpha is fixed, taper angle is fixed. So that equation, if it is in terms of alpha, it is fixed shoes. If it is in terms of MA, means the taper angle it is in MA, then it is become a pivoted shoes equation. Okay. See next, squaring on both sides, alpha square is equal to MA square, alpha square is equal to, in the place of A, I know A is equal to H H2 by B. Okay, I place this value here and it is become H2 square by B square. And in the equation, in the load carrying capacity equation, I just take the load carrying equation. So this is a load carrying equation. Load carrying equation for a fixed shoes. That is, we already derived. You can take it from data and book. Okay, that is W is equal to 6 mu U L by alpha square into ln A minus alpha by A plus 2 alpha by 2A minus alpha. This is the equation from handbook. Okay. So in this equation, if you replace this alpha by M, then it is become an equation for pivoted shoes. So for that, here in the land, here we have to replace this term, here we have to replace this term as well as this term. Alpha square we already got. So alpha square, wherever the alpha square, I just placed M square H2 square by B. Okay. But here A minus alpha by A is there. For that, I have to simplify and substitute in terms of M. Okay. So see here, this is there. One more term is there. That term I have to replace. So 1 minus alpha by A we can place, and alpha by A means we already know that minus M. So minus into minus plus. So A minus alpha by A means 1 plus M. And in this term, we can easily replace alpha minus A minus alpha by A is equal to 1 minus M. And one more term is there here in the second, 2 alpha by 2A minus alpha. Yes, this term. Here, I just split this, okay, 2 alpha means minus MA, A is there, and alpha, so plus. So here take A common, so get cancels. So finally 2M by 2 plus M. This is. So I have this fixed bearing equation. I just replaced alpha in terms of MA. I got all the values, alpha square, this is the value, for this term, this is the value, and for this term, this is the value. So now substitute these 2, 3, 4 equation in one, we'll get load carrying capacity for fixed shoes. See here, this is a pivoted shoes. Okay. So this is an equation from the data handbook, and these terms value just only we got in terms of M, A. Okay, we just replace all these values. See, I substituted here. Okay, I substituted this value and this value and this value. Okay, and take the common outside. Okay. And finally, this term I separated, and only I separate 6 mu U L B square by H2 square into this term. Okay. So this term we can call it as a KW. That you can see in the data handbook. See here, load carrying capacity. This K term, which is KW. So KW, which is equal to 1 by M square ln 1 plus M minus 2 by M into M plus 2. The same thing here. After this simplification, okay, it will remains, and that I written here. W is equal to 6 mu U LB by H2 square KW, where KW is a constant. It is a constant, and that value is 1 by M square ln 1 plus M minus 2 by M into M plus 2. Okay. So So equation 5 is called a load carrying capacity of pivoted shoes. It is for pivoted shoes. Similarly, frictional force. We already have the frictional force value. Okay, this frictional force value from data and book. Okay, so this is a value frictional force for a fixed shoes, but here we just replace this term and this term alpha by ma, so alpha is equal to minus ma. Okay, and simplify, you will get this equation. So here I substituted the values. Previously I got the values, I just substituted, and finally f naught, which is equal to mu u l b by h2 into kf, where kf is the term which is a constant term, 4 by minus m ln 1 plus m plus 6 2 mu 2 plus m. Yes, you can see in the data book. So frictional force kf is there, where kf is equal to 4 by m ln 1 plus m minus 6 to m. Okay, and similarly coefficient of friction, we already know that coefficient of friction means frictional force by load. It's a load, frictional force by load. So we already have that values. Okay, we just substitute these values and cancel the common term, and finally h2 by 6b kf by kw, that we can write f is equal to h2 by b kf by this term 1 by 6 kf by kw means small kf. Small kf is the another constant which is depends on the kf w kw, that we can call it as a equation 7. So this is also available in your data handbook. Say here coefficient of friction kh h2 by b into kf, where kf is equal to kf by 6 kw, and this is the same a distance, center of distance of pivoted bearing, same like a fixed bearing. It is in terms of kf kw k small f. And here one more thing, that m value, I told m is a dimensionless value. Okay, that m value is having a nearly 3 values. One is, if m assume m is equal to 1.2, 1.5 and 1. If m is equal to 1.2, if I assume, or if I value, given value is m is equal to 1.2, then this kf constant value and kf and small kf value are here, and this we can get it in the data handbook. Okay, in the problem they given m is equal to 1.2, then you have to use these values. If m is, it's a maximum load carrying capacity. If minimum friction means m is equal to 1.5, if m is equal to 1.5, the friction is very less, then kf kw are these values. If m is equal to 1, means no condition given. If there is no condition, if the condition is minimum friction, you have to take m is equal to 1.5. If the condition is maximum load capacity, m is equal to 1.5. Or else in the problem they directly given m is equal to 1.2 or 1.5. If no condition given, then assume that m is equal to 1. Then you have to take these values kw, kf and k capital F values. Okay, so all these are available in your data handbook. Yes, this is a table where you get the values. If 1.2, this is a k capital F, k small f, as well as center. Okay, Based on this value, just take 1, 1.5, okay, or else 1, 1.2, like this you have to take the values. This is a table you have to refer. ಅರ್ಥ ಆಯ್ತಾ? See, this is a notes. See, in the notes, I clearly derived pivoted pad bearing, which is clearly depends on fixed shoes bearing. Whatever the derivations we derived and equations, based on those equations, we are just replace the term. Okay, the term m. We just replace that alpha by in terms of m. Okay, here there is no derivation. Actually, we just replace the term by alpha by m and simplify. You will get W, load carrying capacity, frictional force, as well as coefficient of friction. Okay, and these are the three conditions. And based on this, we are going to start some of the numerical problems.